എന്ത് ചെയ്യാനാ ഉടുപ്പ് കയറ്റി വെച്ചിട്ട് ചെയ്യാൻ പറ്റുമോ? Appears to be
Hello, can you hear me?
Yes, ma'am.
Okay, thank you. Good evening, everybody. I hope all participants are present here. So let's start. Today is the third day of AICT Adel Academy sponsored 6-day online faculty development program on the topic Emerging Trends and Applications in Artificial Intelligence and Data Science, which is organized by MAS MK Mackar Pillay College for Advanced Studies, Edathala. Today we are having two sessions. We are moving straight forward to our first session without any delay. Our first session for the day is on the topic Introduction of Machine Learning. To speak on the topic, we are delighted to have an apt resource person with us today, that is Miss Aisha Fina PK. She is a data analyst in Futura Lab Technologies. She has a strong academic background in BSc Statistics. She worked on real-world data projects involving data analysis, machine learning, and visualization. For the past 1 year, she has been working as a data science trainer at Futura Labs, where she mentors students and professionals also in Python programming, machine learning, and data analytic tools. She mainly focuses on making data science clear, practical, and application-oriented. Hence, we believe that we have a right resource person with us today. On behalf of MASMK Mackar Pillay College, I welcome Ms. Aisha Fina ma'am to this FDP. Also, I welcome all the participants to the session. I wish this session would be an insightful one. Without further delay, I think we can start our session. Let's start the talk. I invite Ms. Aisha Fina ma'am to begin the session. Ma'am.
Yes, thank you.
Yes, ma'am, you can start now.
Okay, my name is Aisha Fina. I'm working as a data scientist. I specialize in machine learning, Python programming, and other data analytical tools. So we can start. I hope everyone can see the screen, right? Okay.
Yes.
Good evening all. Today I am going to give an introduction to machine learning. In this section, we will cover the basics of what machine learning is, why it is important, and some key concepts that from its foundation. In this section, we will cover what is machine learning and what the types of machine learning and regression classification. Okay. First, it is what is machine learning? Machine learning is a subset of artificial intelligence that allows computers to learn patterns from data and make predictions or decisions without being explicitly programmed for every step. Machine learning is a branch of artificial intelligence that focuses on teaching computers to learn from data and improve their performance without being explicitly programmed. Instead of fixed instructions written by humans, a machine learning system identifies patterns, relationships, and trends within large amount of data and uses them to make predictions or decisions. Simply saying machine learning is a subset of AI. Machine learning is a subset of AI that allows computers to learn patterns from a data and make predictions or decisions without being explicitly programmed for every step. For example, when we watching a movie on Netflix or YouTube, the platform learns we are viewing history and recommends shows you might like. That is machine learning at work. Machine learning is broadly divided into three main types. Machine learning is mainly three types. One is supervised machine learning, another one is unsupervised machine learning, and the third one is reinforcement machine learning. We will discuss it detailedly later. Mainly supervised machine learning. Machine learning is a subset of artificial intelligence. Supervised machine learning is the where the model learns from labeled data and predicts outcome like house predictions or whether an email is spam. Unsupervised learning, where the model works with unlabeled data to find hidden structures such as grouping customers by purchasing behavior. Coming to reinforcement learning is where the agent learns by interacting with its environment through rewards and penalties. The process of machine learning generally involves collecting data. Machine learning is learning generally involves collecting data, cleaning and preparing it, choosing an appropriate algorithm, training the model, testing its accuracy. In real world application. So machine learning is a branch of artificial intelligence that focusing on teaching computers to learn from data and improve their performance without being explicitly programmed. Okay, that is machine learning, just in definition. And coming to why machine learning, why we are using machine learning. Because it handles large complex data sets, improves automatically as more data comes in. It is useful in real world scenarios like spam, filtering, medical diagnosis, price prediction, etc. Why machine learning is important? Because it allows computers and system to automatically learn and improve from experience without needing to be explicitly programmed every time. Work for simple, but in today's world, we deal massive and complex data that humans cannot analyze manually. This is where machine learning becomes powerful. In now, we deal with massive data that humans cannot analyze manually. In here, this is where machine learning becomes powerful. It helps us discover patterns, make predictions, and automate decision making in real time. For example, a bank use machine learning to detect fraudulent transaction instantly. E-commerce platform like Amazon recommend products based on customer preferences, and healthcare uses machine learning to predict diseases at early stages. Unlike a fixed rules-based system, machine learning continuously adapt as the new data comes in, making it smarter over time. The main reason why machine learning is included because it handling big data efficiently and reducing human effort and improving accuracy, saving time, and enabling innovation like self-driving cars, chatbots, and personalized recommendations. And shortly saying, machine learning is essential today because it makes technology more intelligent, scalable, and useful in solving real-world problems. It was saving time, improving accuracy, reducing human efforts. Machine learning is essential today. That is the reason why machine learning is using. So, nextly, we are talking about types of machine learning. We have three types of machine learning is there. One is supervised learning and another second one is unsupervised learning. The third one is reinforcement learning. First one is supervised machine learning. It trains algorithm based input and output data labeled by humans. Supervised learning is a type of machine learning where the algorithm is trained using labeled data. This means that both the input data and the output data are provided to the model during the training period. The system learns the relationship between the input and the output data. In supervised learning, we will give input data and also the output data. We will provide input and output data to the model during training time. And the system will learn the relationship. What is the relation? System will learn what is the relationship between input and output data. And later it can make predictions on new unseen data. Supervised learning is we will give input data at the time and output data. We will give input and output data together at a training time, and the system will learn the relationship. What is the relationship between input and data, output data? The system will learn, and later it will make a prediction on new unseen data. In the example from this slide, input data is picture of apples. And the annotation or the labels, these are apples. We are giving the input data as apples and also the annotation, these are apples. The model will learn. We will already give the input data and also the label, these are apples. And laterly, the model will learn from these labeled example. When a new picture is shown, the model can correctly predict it's an apple. In this picture, input data is a picture of apple, and the annotation is there are apples. The model learned from the labeled example. When a new picture will shown, the model can correctly predict it's an apple. The picture shows how supervised learning works using apple as an example. On the left side, there are images of apples labeled as these are apples. This represents the input data, pictures, and the annotation or the labels, the correct answer given by humans. These labeled input are passed into the model, shown as a colorful neural network like diagram in the middle. The model learned the relationship between the input images and the labels. On the right side, when a new image is given, the trained model can make a prediction. Here the model predicts it's an apple. In supervised learning, we will give input data and the output data. We will give in this slide, the input data is apple and the output data is these are apples. It's an apple. We're giving input and the output data, and the model will find learn the relationship between input and output data, and it make prediction on new unseen data. That is supervised machine learning. Now machine learning is three types mainly. First one is supervised learning. Trains algorithm based on example input and output data labeled by humans. Okay. The next one is unsupervised learning. What is unsupervised learning? It provides the algorithm unlabeled data in order to allow it to find structure within the input data. Okay. In unsupervised machine learning, unsupervised machine learning is a type of machine learning where the algorithm is given unlabeled data, meaning no predefined outputs or categories are provided. Unlike supervised learning, where the model learns from example with the answer, here the system must find hidden patterns, similarities, or structures within the data on its own. In supervised machine learning, we're giving input and output data. and the system will find the relationship. But when we come to unsupervised learning, here the system must find hidden patterns, similarities, or structures within the data on its own. The main goal of unsupervised learning is exploration and grouping, helping us to understand the underlying structure of large data set. On the left side, we see a box of mixed fruits, apples, bananas, peaches, right? These fruits represent the input data. The left side, apples, banana, peaches, these all are the input data. Notice that they are not labeled. They are not labeled. No one tells the algorithm what each fruit is. In the middle, the model shown as a brain-like network receives this unlabeled data. Since there are no labels, the model has to analyze patterns, similarities, and differences, so it's on its own. On the right side, the model groups the fruits into clusters. Apples are grouped together, bananas are grouped together, peaches are grouped together. And when we coming to unsupervised learning, we only giving input data. We only giving input data. It will find hidden patterns, similarities, or structure within the data by its own. And the model groups the fruits group the input data into clusters. Here are three clusters are there: apple, banana, peaches. This shows how supervised learning works. Instead of predicting outputs from labeled data, it finds hidden patterns and structures within unlabeled data. In unsupervised learning, the model is not given answers. In supervised learning, the model gives answers, but in unsupervised learning, the model is not given answers. It figures out patterns and groups in the data by itself, just like sorting mixed fruits into categories. That is unsupervised learning. Similarly, unsupervised learning is a type of machine learning where the algorithm is given unlabeled data. We only give input data and need to find the hidden patterns, similarities, like kind of things as, and it our model makes groups as clusters. Okay. Okay, when coming to the third type, what?
Unmuted the mic. You can continue, ma'am.
Okay. The third type of machine learning is reinforcement learning. What is reinforcement learning? Concerned with how intelligent agents how to take actions in an environment to maximize the notion of cumulative rewards. Reinforcement learning is a type of machine learning where an agent learns by interacting with an environment and improving its decisions through a system or reward and penalties. Unlike supervised learning, which uses labeled data, or unsupervised learning, which finds hidden patterns. Coming to reinforcement learning is based on trial and error. In reinforcement learning, it is based on trial and error. The agent takes an action, the environment responds, just like that. The reinforcement learning is based on trial and error. The agent takes an action, the environment responds. and the agent receives feedback in the form of a reward, positive, or punishment. It is negative. Over time, the agent learns the best strategy called a policy to maximize the total rewards. A real world example like training robots to walk or perform tasks, or training a dog to walk, self-driving cars, learning safe navigation. In short, we can say reinforcement learning is about learning by doing, just like how humans or animals learn new skills through experience and feedback. So, in machine learning, there are three types of machine learning is there. One is supervised machine learning that trains algorithm based on example input and output data labeled by humans. The next one is unsupervised learning. It provides the algorithm unlabeled data in order to allow it to find structures within the input data. The third one is reinforcement learning. Reinforcement learning is concerned with how intelligent agents outtake actions in an environment to maximize the notion of cumulative rewards. Okay. Types of machine learning, three types are supervised machine learning, unsupervised learning, reinforcement learning. Supervised learning is task driven, unsupervised learning is data driven, reinforcement learning is learned from errors. Okay. Moving on to next types of supervised learning problems. Types of supervised learning problems. There are mainly, we have two types of supervised learning problems. First one is regression. The second one is classification. Regression is when the model is supposed to predict numerical values. It's called a regression problem. For example, house price prediction. When the output variable is a continuous value, a number that can vary. Its goal is to predict numerical values. Regression is when the model is supposed to predict numerical values. It's called a regression problem. For example, predicting house price based on size, location, etc. Forecasting sales on stock prices. That is regression. Regression we using when our model is supposed to predict numerical values. Okay, the second one is classification. When the data is, what is classification is, when the data is supposed to be classified into different classes. When our data is supposed to be classified into different classes, then we use classification. It is a classification problem. The data is supposed to be classified into different classes. It's a classification problem. If there are only two classes, it's a binary classification problem. Example, to predict whether a person has a disease or not. There are two types of classification is there. First one is binary classification. Binary classification is when we have only two classes, then we use binary classification. Example like predict whether a person has a disease or not. If there are more than two classes, when we have two classes, we use binary classification problem. If there are more than two classes, it's a multi-class classification problem. Example, predict whether a student gets grade A, B, C, or D in an examination. Classification problem is when the output variable is a category or class label, discrete values. Regression is continuous values. Classification is discrete values. In classification, our goal is assign input data to predefined categories. Example, email spam detection, spam or not spam. Supervised learning problems are two types mainly. regression, where we predict numbers, and classification, where we predict categories. Okay. In regression, we have a simple linear regression. Simple linear regression. What is simple linear regression? It is the very basic machine learning algorithm to create a model and train. It's based on the equation y equal to mx plus c. Y is the dependent variable and x is the independent variable. M is slope, c is y-intercept. Simple linear regression is one of the most basic and commonly used algorithm in machine learning. One of the most basic and commonly used algorithm in machine learning is simple linear regression. Its main purpose is to find the relationship between two variables. When we have two variables, when we want to find the relationship, then we can use simple linear regression. Simple linear regression main purpose is to find the relationship between two variables. One is independent variable x and other one is dependent variable. Simple linear regression is finding the relationship between two variables. The two variables are, one is independent variable and other one is dependent variable. The relationship is represented using a straight line equation, y equal to mx plus c. Y is the dependent variable. It's also known as target variable. Dependent variable is also known as target variable. Y is the dependent variable and also the target variable. This is what we want to predict. Y is this is what we want to predict. Example, students' mark or house price. And x, the next one is x. X is independent variable, also known as feature. Feature or features, like depending on our data. X is independent variable, y is dependent variable. X is the input or factor affecting the output. X is independent variable, it will be affect the output. Example like steady hour, house size, like. M is slope of the line. It shows how much y changes when x increases by 1 unit. That is M. And with the slope of the line, it shows how much y changes when x increases by 1 unit. Example, m equal to 5, then for every 1 extra steady hour, marks increases by 5. C is the intercept, the point where the line cuts the y-axis. If example, like if a student studies 0 hours, C may represent the minimum marks they can still score. Real life example, like imagine we collecting data on our studies versus exam marks. We collecting data on our studies versus exam marks. Our input is x, is hours studied. Output is y. It's marks scored. By plotting this data and drawing the best fit straight line, we can predict how many marks a student will get for any number of study hours. Simple linear regression is it is one of the most commonly used algorithm in machine learning. Its main purpose is to find the relationship between two variables. One is independent variable and another one is dependent variable. Okay, the relationship is represented using a straight line equation. The equation is y equal to mx plus c. Y is the dependent variable, x is the independent variable, m is the slope, y is the intercept. That's all about the simple linear regression. And the next one is price equal to M into area plus B. Dependent variable, price is the dependent variable. Area is the independent variable. M is the slope. Okay. Simple linear regression. This is an example of simple linear regression. Home price in monolith home price. Simple linear regression. An example of home price. Area is we have two columns here, area and price. Area is our dependent variable and price is area is the independent variable and price is the dependent variable. Area is X, it is independent variable, price is the independent variable. Price will be changed based on the area. That's why price is dependent variable. Okay. Simple linear regression, it only have two variables. In linear regression with multiple variables, it has two or more variables. Want to create when we want to create a model with more than one independent model, that is the dependent variable. Value can predict based on more than one independent variable. Linear regression with multiple variable is when we want to create model with more than one independent model. That is the dependent variable value can predict based on more than one independent variable. In this figure, area, bedroom, ages are my independent variable. Independent variables, area, bedroom, ages are my independent variables, and price is my dependent variable. Multiple linear regression, unlike simple linear regression, which uses one input variable, right? In simple linear regression, which uses one input variable, but when coming to multiple linear regression, it uses two or more independent variable. In here, area, bedroom, ages are the independent variable. Here we have three independent variable. Multiple linear regression uses two or more independent variable to predict the dependent variable. Here my dependent variable is price. Area, bedroom, ages are my independent variables, and the price is my dependent variable. The equation is y equal to m1 x1 plus m2 x2 plus m3 x3 plus b. Y is the dependent variable. Here is price. For the target variable, here house price. x1, x2, x3 all are the independent variable or known as features. In here, area, bedroom, ages are my independent variable. B is the intercept value of y when all x is equal to 1. That is my B. B is my intercept value. Multiple linear regression helps us make more accurate predictions because real world outcomes like house price depend on many factors. Linear regression is two types. One is simple linear regression. It has only one independent variable and one independent variable. Multiple linear regression is when we have two or more independent variable and one dependent variable. Multiple linear regression help us make more accurate predictions because real world outcomes like house price depends on many factors. This is my equation y equal to m1 x1 plus m2 x2 plus m3 x3 plus b. When I add in my example area, bedroom, age, price, my equation will be price equal to m1 star plus m2 into bedrooms plus m3 into age plus b. B is the intercept value. Basic steps in machine learning. We have two steps in machine learning. Machine learning consists of two types typically. One is train the model. We have two steps in machine learning. First one is train the model. Second one is ask question to the model. The more you train the model will be more accurate. But if the training data is so huge, then the training time will be high. The more train the model, when we train the model will be more accurate. But if the training data is so huge, then the training time will be high. So every time training a model is time consuming process. Our first step is train the model. Train the model means we give the model a lot of data with inputs, and in supervised learning, the correct answers. The model studies this data and learns the patterns just like a student learning from textbooks, and that is training the model. First step is training the model. The model studies this data and learn the patterns. Second one is ask questions to the model. Once we trained, we give the model new data it hasn't seen before. The model, after training, we will give the model a new data it hasn't seen before. The model uses what it learned to make predictions or decisions. Training shows the model many pictures of example, like when we show the model many pictures of cats and dogs with labels. We can ask questions like we can give it a new picture. The model answers this is a cat or this is a dog. Mainly two steps are in machine learning. First one is training the model. Second one is ask a question to the model. Training the model is the model studies this data and learns the patterns just like a student's learning from the textbooks, right? The second one is asking question to the model. Once we trained, we can give the model a new data it has seen before. These are the main two steps in machine learning. Train the model and ask question to the model. And moving on to next, splitting the data to train and test. Splitting the data to train and test. Training the model with the entire data set is not a good practice. When we training the model with the entire data set is not a good practice. When the same data set is used for testing the model, it may not reflect the actual performance of the model. When we using data set, the same data set used testing the model, it may not reflect the actual performance of the model. So in machine learning, the data set is split into two parts. The first part is for training the model. The second part is testing the model. When we training the model with entire data set is not a good thing. So in machine learning, we can split the data into two parts. First part is for training the model. The second part is for testing the model. We have mainly two parts. We can split our data into two parts, one for training, one for testing. This ensures that the model has not seen the testing data during the training phase. Splitting the data into train and test. In machine learning, we don't train the model on the entire data set because that would make the model too familiar with the data, and it may not perform well on new unseen data. This problem is called overfitting. In machine learning, we don't train the model on the entire data set because that would make the model too familiar with the data. and it may not perform well on new or unseen data. This problem is called overfitting. What is overfitting? We don't train when we training the same ended data set, because that would make the model too familiar with the data, and it may not perform well on new unseen data. This problem is called overfitting. So we want to overcome the problem. To avoid this, we can split the data set into two parts. One is training. Training is used to teach the model. We have two parts. One is training, one is testing. Training is for used to teach the model. The model learns patterns and relationship from the portion of data. Basically, two parts are there. First one is training. Training is for use. Training is used to teach the model. The model learns patterns and relationships from the portion of training data. Usually around 70 to 80% of data that be given to training data. The second one is testing data, used to evaluate the model's performance. The model has never seen this data before, so testing shows how well the model works in real-time situations, usually around 20 to 30% of data. We have in our data set, we can split into two parts for a good score we want to get. In machine learning, the data set is split into two parts. First one is training and the second one is testing. Training is for teach the model. The model learns patterns and relationship from this portion. The training portion is the data for teaching. The model learns patterns and relationship from this pattern. Usually we use around 70 to 80% of data. Example, like suppose suppose we have 100 students records, study hours and marks. We split them. 80 students of data for training to build the model. We have 100 students records about study hours and marks. We are going to splitting the data. 80 students data for training to build the model. 20 students data for testing to check accuracy. This way, the test accuracy reflects how well the model will perform on new student it has since seen. Splitting the dataset into training and testing ensures the model learn well, but it also tests fairly on unseen data, giving us a true measure of its performance. Splitting the data to train and test. Training is for to teach the model. Testing is for to evaluate the model's performance. Okay. I'm going to show you how to create simple linear regression and multiple linear regression. First, we want to import warnings for remove warnings. And I'm importing pandas as PD. Yeah. I have a home place data. I have a data, it is home place data, area and price. Area is my independent variable, y is my dependent variable. So I want to extract. X is my independent variable, that is area. Y is my dependent variable, that is price. So I want to extract them into X and Y. X is my X. In X, I want area only. So I drop in price. My X is equal to 1. My X is equal to 1 is, I am dropping this column wisely. When you want to drop anything row wisely, its X is equal to 0, right? Or by default, it's row wise. In my data, area is area and price. Simple linear regression we use only when we have two parts. In here, we have two parts, area and price, one dependent variable and one independent variable. X is my independent variable, so I'm extracting area from my data, data.drop price, comma X is equal to 1. So I can get X as area. That's my independent variable. Nextly, I am extracting my dependent variable, y equal to data of price. Data is my data set is area price. I only want dependent variable, that is price. So I give it to them. So I get the independent variable in X, dependent variable in Y. So I'm going to training. First, I want to import linear regression. From where we import a linear regression? From sklearn.linear model, import linear regression. From sklearn.linear model, we want to import linear regression. So then in this line, linear regression is imported. So nextly, we want to create our model. How to create model? Model equal to model is linear regression. So I give it a model equal to linear regression, and I want to fit model dot fit x comma y. X is my independent variable. Y is my dependent variable. Why we are fitting, analyzing, and study to find a best fit, training the model. So here, this is my model, and I want to, when you want to find the slope, just give a model dot coefficient. It's coefficient, that's slope value. When you want interception value, this model is my in linear regression. Just give it a thumb. So we will get intercept value. Nextly, I'm going to predict. We want to predict. I give a variable ypred equal to model dot predict. I want to predict my predict with x. When I predict, this is my x, and I'm going to predict this with a new dependent variable. So model dot predict with x. I got these values. I want to see true y values and predicted y values. My original y values, so I make the data frame for true y values, and that's my y I already have in my data set. Predicted y values I predicted with x. That is my predicted y value. I want to see these things as in one data frame, so I created a data frame. This is my original y values in my data price. This is my original data, and I predicted these values. These all are almost approximately value. And nextly, I just plotted my x and y independent variable and dependent variable. It's a straight line. Why? Because it's a linear regression. Linear regression, simple linear regression is a straight line. We already discussed y equal to nmax plus c. This is becomes a straight line. So nextly, I want to predict a new value. So I give the model is my linear regression. So model dot predict, it's a new value. 3,700 is my new value. So I just gave, I got the new y value here. This is x, new x value, and I got a new y value. When you want, at a time you want to predict more values, just give to double square, and then I got these predicted y values. And I want to find the score, just give a model dot score. Model dot score is 0.95. Okay. Model dot score is, here I got the score is 0.95. In here, finding how accurate the model. Accuracy is in machine learning. After training a model, we need to check how well it performs. One simple way is using model dot score of x comma y to accurate our model. Just give a model dot score of x comma y. X is the input feature independent variable. Y is the actual output value dependent variable. Model dot score returns the accuracy of the model. Here we give the accuracy of the model. How close predictions are to the actual values. In regression model, model dot score of x comma y returns the R-square score, coefficient of determination. R-square ranges between 0 and 1. One is the one becomes the perfect prediction. 0 models does not explain variation at all. In this in classification model dot score of x comma y return the accuracy. So here we are finding the accuracy. Model dot score of x comma y is the accuracy. We got the accuracy 0.95. It's a simple linear regression. We also discussed about a multilinear regression. What is multilinear regression? When we have two or more independent variable. When we have two or more independent variables. In this, y is my dependent variable. Y is here is price. Price is my dependent variable. Area, bedroom, ages are my independent variable. Multiple linear regression we using when we have more than two or more independent variable. Here independent variables are area, bedroom, age. And my dependent variable is price. So first I checked, is there any null value in my data set? I found one null value in bedroom. So I want to handle how we can handle it. I used mean equal to data of bedroom. In this bedroom mean, I found the mean in the column and I handled using filter and I got a cleaned data set. After I just plotted a scatter plot data dot bedroom, we have three independent variables. So first I just plot a scatter plot for bedrooms and price. This is my first scatter plot of bedrooms and price. In x-axis, bedrooms are there. In y-axis, price is there. Okay. And nextly, I plot a scatter plot about age and price. Nextly, I plot a scatter plot of area and price. This is my data now. My data have for columns area, bedroom, age, price. Area, bedroom, ages are my independent variable and price is my dependent variable. So I just want to train and then I want to find the score. So I want to extract the dependent variable and the independent variable. First I extracted my dependent variable, that is y. That in my data set dependent variable is price. So I extract price into y. I got my price values. Next, I'm going to extracting my dependent variables that are age, bedroom, age. So I dropped price When I go, then I got the independent variable area, bedroom, age. Now I got the dependent variable and the independent variable. Now I want to train my model. First, we already discussed train splitting the data set. Splitting the data set in machine learning, the data set is split into two parts. The first part is training, and the second part is testing. So here I want to import train test split from where from the sklearn.model selection. I want to import train test split. X train, X test, Y train, Y test equal to train test split of X comma Y test size. Test size is how much I want to give into test. That is test size. I give 0.2. Random states ensures reproducible result by controlling randomness. So I give 20. And I want to import linear regression from sklearn.linear model. And my model is linear regression model.fit X train, Y train. Here my model is linear regression. And then nextly I want to predict widespread train is model.predict X train. I predict my model with X train. I got my new values. I found my score from classification problem. I got score is 1. Okay. Coming to PDF. Mainly two types of regressions is there. First one is linear regression. Second one is logistic regression. Linear regression is two types: simple linear regression and multiple linear regression. And next one is logistic regression. Logistic regression is used to predict classification problems. Logistic regression is used to predict classification problems. There are two categories is there. First one is binary logistic regression for binary classification. Second one first one is binary logistic regression for binary classification, and second one is multivariable logistic regression for multi-class classification. Logistic regression is a classification, but it's called. Oh, yes.
Ma'am, I guess there is a doubt in the chat box.
Okay.
Ma'am, it is from Patel Falguni Ben. Have you seen the message?
No, I didn't.
It is in the chat box, like on 6:59 p.m. The message. Do you want me to read it out?
Yes.
Yes. So the doubt is, can we see slope and intercept value in Python for simple and multilinear regression? Ma'am, was I clear enough? Should I read it again?
If you want to see intercept value and slope in multi linear regression, right?
Yes, ma'am. He's asking, can we see slope and intercept value in Python for simple and multilinear regression?
In simple linear regression, I already here it is the coefficient is sloping value. Just print model dot coefficient gives the sloping value. It is 135.78, and the intercept value is just give model dot intercept. So we can we will get the intercept value.
Dr. Patel, I guess the doubt is clear. Do you want to ask anything else, or can we move on? Okay, ma'am, let's continue. Thank you.
Okay. Moving to logistic regression. Logistic regression is used to predict classification problems. There are two categories. First one is binary logistic regression for binary classification, and the second one is multivariable logistic regression for multi-class classification. Logistic regression is a classification, but it's called as regression. Why it's called logistic regression instead of classification? It has many reasons. Historical and mathematical reasons are logistic regression was originally developed as an extension of linear regression to model probabilities that a certain event belongs to a class, like yes or no, or 0 or 1. It models the log odds linearly. Logistic regression predicts the log odds of the probabilities of the outcome as a linear function of the inputs. This part is called the regression aspect because it fits a linear equation on the log odds scale. This is the reason why logistic regression is known as regression. It's a classification problem, but it's called logistic regression. In logistic regression classification, okay. Moving to classification problems using linear regression. Logistic regression is a machine learning algorithm used for classification problems. Instead of predicting continuous values like linear regression, it predicts whether some, yes. Hello.
Nothing, ma'am. You can continue. Nothing. Yeah.
Logistic regression is a machine learning algorithm used for classification problems. Instead of predicting continuous values like linear regression, it predicts whether something belongs to a class. There are two main types. Binary logistic regression, when the outcomes as two classes, yes or no, or spam, not spam, 0, 1. It's called binary logistic regression. Multinomial logistic regression is when the outcome has more than two classes. Example, like classifying fruits as apple, orange, mangoes, just like that. Moving on to classification problems using linear regression. In this picture, showing why using linear regression for a classification problem is not ideal. The example is about predicting whether a person has insurance. Yes is 1, no is 0, based on age. In x-axis, age of a person is shown. In y-axis, whether the person has insurance. 0 is no, 1 is yes. The red points are actual data. People with insurance are at y equal to 1. people without insurance are at y equals 0. The blue line is the best fit line obtained from linear regression. Problems with the linear regression for classification is prediction not bounded between 0 and 1. Linear regression gives continuous values. In classification, we only want 0 or 1, or probabilities between 0 and 1. But the line may predict values like minus or 1.2, which make no sense for probabilities. Decision boundaries is arbitrary. Here is instead of this works purely because linear regression is not designed for classification boundaries. Not instead of linear regression, we usually use logistic regression for classification. That is the correct approach. Instead of linear regression, we want to use logistic regression. It has a solution that is logistic regression, logistic function, also known as sigmoid function. In this graph, x-axis have age of a person, y-axis have probability of having insurance between 0 and 1. The red points are the actual data. Same as before, 0 is no, insurance is 1. 0 is no insurance, 1 is has insurance. The blue curve is the logistic or sigmoid function fit to the data. The S-shaped curve known as sigmoid function. The S-shaped curve sigmoid function is a mathematical function that smoothly maps any real number into a value between 0 and 1, representing probabilities. The dotted horizontal line at 0.5 is the cutoff. Dotted horizontal line at 0.5 is the cutoff. If our probability greater than or equal to 0.5, it will classify as 1. It has insurance. If probability greater than 0.5, it will classify as 0. That is no insurance. The vertical dotted line shows the approximate age threshold where classification flips from 0 to 1. Why logistic regression works better is because predictions are always between 0 and 1. It provides a clear probability interpretations. Yeah, that's why logistic regression works better. In this picture, left side is x-axis have input variable x. For example, age. X-axis is input variable, that is x. In this example, in x-axis have age. In y-axis, it's output. X-axis is x and our y-axis have output. That is probability. For target value, that is y. In linear model, that is the blue line. Blue line indicate a linear model, and the orange line, orange S-shaped curve indicates logistic model. In linear model, the blue line, its equation is y equal to b0 plus b1x. Blue line is the linear model, that its equation is y equal to b0 plus b1x. The logistic model, orange S-shape S curve, its equation is b equal to 1 by 1 plus e raised to minus b0 plus b1x. It converts, this is the sigmoid function. Logistic model, this is the sigmoid function. It converts the linear output into a probability between 0 and 1. Linear regression is unbounded, goes to negative infinity and positive infinity. Logistic regression squeezes the input into 0 and 1, which make it ideal for binary classification. Example like yes or no, 0, 1, true, false. Okay. Logistic, moving on, logistic regression with the multi-class. This kind of problem will have multiple classification, like which team will win the T20 World Cup. It's having multiple options. When we have multiple options, then we use logistic regression. We are going to identify handwritten digit recognition. In logistic regression with multiple class. Logistic regression isn't limited to just binary classification 0 or 1. It can also be extended to multi-class classification using approaches like one versus rest. First one, logistic regression model per class. I will give you an example for logistic regression. Logistic regression is two-type: binary logistic regression and multi-class logistic regression. In binary logistic regression, there is only two classes here: age and what insurance. This is my data. I just plotted a scatter plot. It's shown as a S-shaped curve. It also known as sigmoid curve. I just find its shape, data dot shape. We can get the shape: 22 rows and 2 columns. This is the shape. I want to extract my dependent variable and independent variable. Y is my dependent variable. I extract from data, that's what insurance. I extract my independent variable, that is what insurance. Yeah. So this is my data. It has more columns. Logistic regression is about is machine learning algorithm used for classification problems. Multinomial logistic regression is when the outcome has more than 2 classes. Here we have a lot of classes, so we're using multiple linear regression. First, I want to import my train test split for splitting the data to train and test. From sklearn.linear model, import logistic regression. My model is logistic regression, model.fit xtrain, ytrain. And here is my model is created. And finally, I'm checking my score, model.score of x test and y test. Yeah. I got my score is 0.5. Logistic regression is with multi-class. This kind of problems will have multi-classification. when we have 2 classification, we use binary classification. Binary logistic regression for binary classification when we have 2 classes. And the second one is multi-variable logistic regression, that is multi-class classification when we have more than 2 classes, when we use multi-variable logistic regression. When we have 2 classes, we never 2 or more classes, we never use linear regression. In classification, we never use linear regression. In classification, we only use logistic regression. It's also known as S-shaped curve. The S-shaped curve is a mathematical function that smoothly maps any real number into a value between 0 and 1. In this, from a scalar dot linear model, import logistic regression. X is my feature, input feature. Y is my output level. My model is logistic regression. It creates a logistic regression classifier. Fit X comma Y is, trains the model to learn the relationship between steady error and outcome. Here, logistic regression. First, I have X and Y. X is my independent variable. Y is my dependent variable. And nextly, I'm predicting model dot predict the class level 0 or 5 for hour, and model dot predict proba. Predict proba means it predicts the probabilities for each class. Predict is for predicting the class labels. Predict proba is for predicts the probabilities for each class. Example like 30% of chance of fail, it becomes class 0. 70% of chance of pass, it becomes class 1. Prediction for 5 hours, the model decided the most likely outcome. Probability is pass. Probability for 5 hours, the model gives the probability distribution across classes like 30 versus 70. In logistic regression with the multi-class, this is my data for logistic regression for my multi-classification. I have more than 2 dependent variables, and my independent variable is salary. So we can find the score from here. Today we discussed about machine learning. Introduction to machine learning. We discussed about what is machine learning. Machine learning is a subset of artificial intelligence that allows computer to learn pattern from data and make predictions or decisions without being explicitly programmed for every step. This is the definition for machine learning, and we talked why machine learning. Machine learning helps, it handles large data, and it helps for time consuming. So we use machine learning. The main resource why machine learning is needed included handling big data effectively, reducing human effort, improving accuracy. Three types of machine learning is, one is supervised learning, second one is unsupervised learning, third one is reinforcement learning. Supervised learning, we give input data and output data, and the model find the relationship between input data and the output data, and it gives the result.
चार्जर ला के दिए मुझे।
What?
Nothing, ma'am.
Okay. There are 3 types of machine learning. Supervised machine learning. In supervised machine learning, it trains algorithm based on example and output data labeled by humans. Second one is unsupervised learning. Provides the algorithm unlabeled data in order to allow it to find structure within the input data. Reinforcement learning, it's like a reward and punishment, concerned with how intelligence agents to take actions in an environment to maximize the notion of cumulative rewards. 3 types:
Ma'am.
supervised, unsupervised.
Ma'am, I guess there is a doubt in the chat box. Can you just look at it?
Can you read that?
Yes. It is from M. Aishwarya. She's asking, may I know the difference between AI, or ML or deep learning?
Okay.
Yes, ma'am, that is the doubt. She wants to know the difference between AI or ML or deep learning.
AI, ML, and deep learning. AI is the artificial intelligence. Its definition is AI refers to the development of computer systems that can perform tasks that typically require human intelligence, such as learning, problem solving, reasoning, perception. A scope is A encompasses a broad range of techniques, including rule-based system, decision trees, and more. A refers to the development of computer system that can perform tasks that typically require human intelligence. Such intelligence. It is A. Machine learning is a subset of AI. AI refers to the development of computer system that can perform tasks that typically require human intelligence. Machine learning is the subset of AI that focusing on developing algorithms that enable computers to learn from data and improve their performance over time. Its key aspects like machine learning algorithm learn from data without being explicitly programmed. That's supervised, unsupervised, and reinforcement learning. And coming to deep learning is a subset of machine learning that uses neural network with multiple layers to learn complex pattern in data. Its key aspect is deep learning is models can learn hierarchical representations of data, enabling them to recognize patterns in images, speech, and text. Its application is image recognizing natural language processing, speech recognition, and more. AI is like a large umbrella covering various techniques. Machine learning is a specific type of technique under the AI umbrella. Deep learning is a specialized technique within machine learning that uses neural network. I think you got it, my point.
Aishwarya, is it clear? Do you want any more clarifications? Okay, ma'am. It is clear for her.
Okay.
Okay, ma'am. So are there any other doubts? Or shall we wind up the session? Ma'am, Aishwarya is asking for an example.
Okay. In artificial intelligence, the self-drive, we can say self-drive example as self-driving car. Artificial intelligence, the self-driving cars computer system uses various techniques to navigate roads, recognize objects, and make decisions. Its goal is the AI system aims to drive safely and efficiently. In machine learning algorithm, when coming to machine learning algorithm, the self-driving car system uses machine learning algorithms to learn from sensor data, example cameras, GPS, and improves its driving decisions over time. Example like the machine learning algorithm learns to recognize stop sign and landmarks markings. In deep learning, consider a self-driving car. And when coming to deep learning, the self-driving car system uses a deep learning model, like example, convolution neural network to analyze camera images and detect objects such as cars and road signs. Example, that deep learning models learn to recognize pedestrians in various environment, lighting condition and poses. In this, just saying, AI is the overall system that enables self-driving capabilities. AI is the overall system. AI is the overall system that enables self-driving capabilities. Machine learning is the technique used to learn from data and improve driving decisions. Deep learning is a specific type of machine learning technique used for object detection and recognition. Yeah, I hope you got it.
Okay, ma'am. I hope it is clear for Aishwarya. So, ma'am, are we continuing or are we coming to the end of the session? Are there any other topics left for us to?
No, it's done.
Okay,
I
ma'am.
covered all my points. Thank you.
Okay, ma'am. Ma'am, it was really good. It was a very enlightening session. Thank you, ma'am. If you want to take a break.
Okay, thank you.
Thank you so much, ma'am. Thank you.
Dear participants, the session 5 feedback form is in the chat box. Please fill it now as it is linked with your attendance. And also there's an important announcement that from today onwards, from day 3 onwards, while filling out the feedback forms, please ensure that you entered your participant ID number. The participant ID number is shared in your WhatsApp group. So please note down your participant ID number, and while filling your feedback form, please fill that portion also. So make sure you filled your feedback form today, now itself, and we'll be back after 10 minutes after a short break.
Madam, the serial number
Yeah.
itself is the ID, no? In the PDF.
Yeah, yes, it's the serial number is the ID number, participant ID number. So we'll take a 10 minutes break. And
Madam, I
yeah.
haven't got the ID number, although I'm attending the classes. So I haven't got, my name is not enlisted over there in the list.
The ID number is in the WhatsApp group. Are you there in the WhatsApp group?
Yes, ma'am. But my name is not there actually.
Can you please check it? Your name is Ashim Ghosh?
Yeah, yes, ma'am.
Let me go through the list, okay?
You, ma'am.
Can you please give a personal message to the coordinators?
Madam, what is the WhatsApp number actually? Because it admin is there. No, madam. We're not able to send any message.
Let me check. Mr. Ashim Ghosh.
Yes, ma'am.
Sir, can you please send a personal message to the coordinators? The numbers of coordinators are there on the poster.
Poster.
They need to clarify whether you are an approved participant or not. So can you please send a personal message to them?
This, madam, this one, Gurupriya Saran.
What? The
Madam,
name of the coordinator is Shahana PS or Gurupriya
yes.
or Gurupriya. You can message any one of them.
Okay.
Okay.
Gurupriya is there. Okay.
Yeah, you can message her.
Okay, madam. Thank you, madam.
Okay. Thank you.
Madam, I can send this one feedback form without this one ID.
What?
I can send feedback form.
Sorry,
I
I didn't
send?
get you. Sorry, I didn't get
Yes.
you.
Madam, I can send feedback form.
You can just send a message to that personal number so that they will check whether you are approved participant or not.
Okay, ma'am.
We have provided participant number only for the approved participants.
Okay, ma'am.
Okay. Hello all. So hope you all are back after the short break. We are moving to our session 2. Before that, thank you Aisha ma'am for your valuable class. It was a detailed session, and thank you for your good talk about introduction to machine learning. Thank you ma'am. So we are moving to the second session. Today's second session is on the topic supervised learning. It is handled by Miss Stemi Stephen. She's a data scientist in Futura Lab Technologies. Ms. Stemi Stephen holds a postgraduate degree and brings over 10 years of experience across academia and robotic engineering and data science. She has worked as a lecturer at Government Engineering College, as a robotic engineer at Inker Robotics, and currently as a data scientist at Futura Labs. Her expertise lies in machine learning, predictive modeling, and visualization for actionable insights. And Steffi ma'am is a familiar face for all of us by yesterday's class itself. So I think there is no more introduction needed for Steffi ma'am. So we are moving straight forward to the session. Ma'am, are you there? Okay, ma'am. So let's start the session.
Okay.
Okay, ma'am. You can start.
Hi, good evening all. First of all, I would like to thank MBS for giving me a great opportunity. And myself, Stemi, I'm working as a data science trainer at Futura Labs. So let's start our session. Okay. Today, we learn about supervised learning. So what is machine learning? Machine learning is a branch of artificial intelligence that works on algorithm developments and statistical models that allow computers to learn from data and make predictions or decisions without being programmed. In machine learning, algorithm development is core work. These algorithms are trained on data to learn the hidden patterns and make predictions based on what they learn. The whole process of training the algorithm is termed as model building. So, how does machine learning work? Machine learning process include project setup, data preparation, modeling, and deployment. So, what is project setup? This is the starting phase where you define the goal and direction of the project. Understand what problem you want ML to solve. Example, the sales prediction or classifying images, etc. The second step is data preparation. This is the most time-consuming phase. So the first one is data collection, gather the data from the database or files. And second is data cleaning. That means handling missing values or duplicates and errors. Third session is data transformation. That means normalize or standardization or scaling features. Third portion is modeling. Here you apply ML algorithms to the data. Model selection means choose the right ML approach. That means we have decision trees or random forest, etc. based on the problem type. Then training the model. Feed the training data into the algorithm to learn patterns. Okay, last step is deployment. That means put model into real world use. Okay. Next, introduction to supervised learning. That means the types of machine learning, mainly 3 types: supervised learning, unsupervised learning, and reinforcement learning. What is supervised machine learning? It is a type of machine learning that trains the model using labeled dataset to predict outcomes. Here, the algorithm is trained on labeled data. meaning that the correct answer or output is provided for each input. The algorithms then uses this labeled data to make predictions about new or unseen data. In the case of unsupervised machine learning, it is a type of machine learning that learns patterns and structures within the data without human supervision. Here, the algorithm is trained on unlabeled data, meaning that the correct output or answer is not provided for each input. Instead, the algorithm must identify the patterns and structures in the data on its own. Here, we are focusing on more on supervised learning, while other types of machine learning will be explained in the upcoming sessions. So, how does supervised learning work? In supervised machine learning, models are trained using a dataset that consists of input-output pairs. The supervised learning algorithm analyzes the dataset and learns the relation between the input data, that means features, and correct output, that means our target. In the process of training, the model estimates the algorithm's parameter by minimizing a loss function. The loss function measures the difference between the model's predictions and actual target values. Okay. The model iteratively updates its parameter until the errors has been sufficiently minimized. So, once the training is completed, the model parameter have optimal values. The model has learned the optimal relation between the input and target. Now, the model can predict values for the new and unseen input data. Clear? Next type of supervised learning algorithm. Two types are the classification and regression. First, classification. The key objective of classification-based task is to predict categorical output labels or response for the given input data, such as true or false, or male or female, or yes or no, etc. In the case of regression method, the key objective of a regression-based task is to predict output labels or response which are continuous numeric values for the given input data. Basically, regression models use the input data features, that is independent variables, and their corresponding continuous numeric output values, that means dependent or outcome variables, to learn specific associations between input and corresponding outputs. There are several algorithms available for supervised learning. Some of them widely used algorithms are linear regression, logistic regression, and decision tree, random forest, SVM, etc. In the case of linear regression, it's a type of algorithm that tries to find the linear relationship between the input features and the output values for the prediction of future events. This algorithm is widely used to perform stock analysis or weather forecasting, etc. Second one is logistic regression. The logistic regression is a type of statistical algorithms that estimate the probability of occurrence of an event. Clear? Next, we discuss about decision tree and random forest. Okay. First one, decision tree. The decision tree algorithms is a hierarchical tree-based algorithm that is used to classify or predict outcomes based on a set of rules. It works by splitting the data into subsets based on the values of the input features. The algorithm recursively splits the data until it reaches a point where the data in each subset belongs to the same class or has the same value for the target variable. The resulting tree is a set of decision rules that can be used to make prediction or classify new data. The decision tree algorithms works by selecting the best feature to split the data at each node. The best feature is the one that provides the most information gain. Information gain is the measure of amount of information gained by splitting the data at a particular feature. The algorithms uses these measures to determine the best feature to split the data at each node. Next use case. A common use case of a decision tree in the field of loan approval in banking. Banks often receive thousands of loan applications, and they need to decide whether to approve or reject each one. A decision tree can be trained on past data, including the applicant details such as income, credit score, employment status, loan amount, etc. The tree then learns decision rules. For example, if credit score is high and income is above a certain level, approve the loan. Otherwise, check employment stability or previous defaults. This structured step-by-step decision-making process makes it easy to interpret or explain to stakeholders and automate in real-world applications. Clear? Okay. Next, anatomy of a decision tree. The anatomy of a decision tree consists of three main components. That means the root node, internal node, branches, and leaf node. First one is root node. In a decision tree, the root node is the very first node at the top of the tree, representing the entire data set. It is the point where the algorithms makes the most important split based on the feature that best separate the data according to target variable. For example, in a loan approval case, the root node might be credit score because it is the strongest factor in determining whether the loan should be approved or not. From this root node, the dataset is divided into branches such as high credit score or low credit score, etc., which then lead to further splits until the final decisions are reached. The root node is crucial because the quality of the initial split greatly influence the accuracy and efficiency of the entire tree. Okay, the next node is internal node. In a decision tree, an internal node is any node that comes after the root node and represent the further decision or split based on the another feature of the dataset. These nodes are used to refine the classification or prediction by dividing the data into smaller more homogeneous groups. For instance, in the loan approval case, if the root node is credit score, the internal node could be annual income or employment status. After splitting the applicants by credit score, and the internal node applies an additional condition such as if income is above a certain threshold, proceed towards approval. Otherwise, check employment stability. These internal nodes guide the path of decision making until the data reaches the leaf node where the final outcome is determined. Second node is branches. In a decision tree, branches are the connections between the nodes that represent the outcome of a decision or test condition. Each branch shows the possible values of a feature and directs the flow towards the next node. For example, in the loan approval case, if the root node is credit score, the branches should be high credit score and low credit score. From the high credit score branch, the decision might move to another internal node, like annual income, while the low credit score branch might be directly led to leaf node indicating loan rejection. In this way, branches act as pathways that link different decision points together, guiding the process from root node and down to the final prediction. Next node is leaf node. Leaf node or terminal nodes are the final node that represent the outcomes or prediction after all decision and splits have been made. They do not split any further. In the loan approval case, leaf nodes could represent decisions such as approved loan or reject loan. Once a data point reaches a leaf node, it has followed a path through the row, followed by the path through the root and internal nodes based on its feature values. And the leaf nodes provides the final result. The leaf nodes are the crucial because they give the actionable output of the decision tree, making the model easy to interpret and apply in real world scenario. Okay. Next, how decision tree works. First, splitting based on features. In the case of decision tree, the decision tree divides the dataset into smaller subsets by selecting features that best separate the data. Each split is like asking a question about a feature to create groups that are more homogeneous in terms of the target variable. Second, metrics used for splitting. To decide which feature to split on, decision tree use quantitative measures. First one is Gini index and second one is entropy and information gain. Gini index means that measures the impurity of a node. A lower Gini value means that the node is more pure. It's contained mostly one class. In the case of entropy and information gain, entropy measures uncertainty in the data, and information gain calculate how much a split reduces this uncertainty. The feature with the highest information gain is chosen for the split. Okay. Next one, recursive partitioning. Splitting continuous recursively, meaning each new subset can be split further using the same process. This continuous until one of these conditions is met. That means pure nodes, a node contains data points of only one class. Okay. Stopping criteria means predefined limits like maximum tree depth, minimum number of samples in a node, or a minimal information gain, etc. This step by step.
Hello, ma'am.
Yeah. Yeah.
Ma'am, I don't know if you moved from the topic, but Aishwarya is saying that she didn't understand something. Can you please check the chat box?
Aishwarya, I will be explain this decision tree by using a data set, and also and then you can be able to understand. Okay.
Okay,
Ma'am.
ma'am. That will be fine, ma'am. Thank you.
Okay. Okay.
And also, I have to remind one thing to the participants that you have to unmute yourself and ask the question. Otherwise, ma'am have to close her presentation, right, ma'am?
Yeah.
Yeah, so it will be better
Otherwise,
if
I
you...
can't see the questions.
Yes, she won't be able to see the chat box. So I would encourage participants to unmute yourself and answer the questions whenever you have a doubt. Okay,
Yes,
thank
ma'am.
you.
Understood, ma'am.
Okay, Aishwarya. Okay. Thank you. You can continue, ma'am.
Okay. I think the last section is how can be decision tree works, and splitting based on features and users metrics and recursive partition until the pure nodes or stopping criteria met. This step-by-step splitting the forms the hierarchical structure of a decision tree, making it easier to interpret and apply for predictions. So there is an example. This is the decision tree diagram that predicts whether a customer will make a purchase based on certain features. Let's break it down step by step. Okay. First, root node. Root node is here, income is greater than $50,000. Okay, this is the first decision point or root node and the most important feature. If income is greater than $50,000, then go yes. Go to the next decision about age. In case it's not greater than, it's go to no. Directly lead to no purchase, or that means leaf node. This shows that income is a strong factor in predicting purchase behavior. Is it clear? Here, this is the decision tree diagram that predicts whether a customer will make a purchase based on certain features. Let's break it down step by step. Okay, first node is root node. Here, this is the first decision point. That means income is greater than $50,000. And if income is greater than $50,000, is go to yes. Go to the next decision about age. In case if it's no, directly leads to no purchase. That means our leaf node. Clear? Okay. Our first internal node is age is greater than 30. This node further splits the group of people with income is greater than $50,000. If the age is greater than 30 and the income is greater than $50,000, then go check previous, if yes, previous purchase, or is no, leads to no purchase. This indicates that age also influence purchase likelihood. Clear? And the second internal node is previous purchase is greater than 0. This node considers whether the customer has purchased before or not. If yes, leads to purchase. That means our leaf node. If not purchase, no, it leads to no purchase. This shows that past purchase behavior is another key predictor. Is it clear? Our root node is income is greater than $50,000. Our first internal node is age is greater than 30. Our second internal node is previous purchase is greater than 0. Okay. Last, the leaf nodes. Leaf node is purchase or no purchase. If the final decision when all conditions are satisfied, we will purchase. Or the final decision if any conditions fails, no purchase. Is it clear? Aishwarya? Okay. The tree follows a top-down approach, asking questions at each node. Branches represent possible answers, yes or no. Leaf nodes give the final outcome. Okay. And explain the example once again. We have different nodes. The first node is root node. It must be greater than income. It must be greater than $50,000. And then this is the first decision point and the most important feature. If it is yes, go to the next decision about the age. If it's no, it directly leads to no purchase. And the first internal node is age is greater than 30. This node further split the age, split the group of people with income is greater than 50,000 and or age is greater than 30. If yes, check previous purchase, or no, leads to no purchase. Our second internal node is previous purchase is greater than 0. This node is considered whether the customer has purchased before. So yes, in case of yes, leads to purchase, or otherwise no, leads to no purchase. Our last node is leaf node. It is purchase or no purchase. The final decision when all conditions are satisfied, it will be purchase. Or if any condition fails, it's no purchase. Is it clear? Okay. Next, the key concepts of entropy and information gain. Okay. Entropy means it measures the uncertainty in a data set. That means scale. 0 means completely pure. That means all data belongs to one class. Scale 1 means maximum disorder. That means data is evenly split among classes. Okay. Entropy means that it measures the uncertainty in a data set. It has two scales, 0 or 1. 0 means completely pure, that all data belongs to one class. And next scale is 1, maximum disorder. That means data is evenly split among classes. Suppose we have 10 loan applications. Among them, 7 is approved and 3 is rejected. This means that the data is not completely pure. So there is some uncertainty. Entropy helps quantify that uncertainty. That means I think you know what's the equation for entropy. Entropy is nothing but it's equal to probability of first character log in the log to the base 2 and minus the probability of second outcomes base to the log 2, where P1 and probability of each classes. It's nothing but it measures uncertainty in a data set. Uncertainty measured by using probability. Next one is information gain. Information gain measures how much uncertainty is reduced after splitting the data based on a feature. We choose the feature that maximizes information gain to make the split because it gives the most clarity about the outcome. Clear? Information gain measures how much uncertainty is reduced after splitting the data based on a feature. We choose the feature that maximizes information gain to make the split because it gives the most clarity about the outcomes. For example, we have a feature like credit score and income level. We know that credit score is high or low and income level is high or low. Suppose splitting on credit score reduces entropy more than splitting on income. Then credit score will be chosen as the first split in a decision tree because it gives the highest information gain. Is it clear? Example, we have two features like credit score and income level. Suppose splitting on a credit score reduces entropy more than splitting on income, then credit score will be chosen as the first split in the decision tree because it gives the highest information gain. Clear? Next is alternative split criteria, Gini impurity. Gini impurity measures the likelihood of misclassifying a randomly chosen data point if we randomly assign labels according to the distribution in the group. Okay, Gini impurity measures the likelihood of misclassifying a randomly chosen data point. It have to scale 0 or closer to 0.5. 0 means completely pure. That is all points belong to one class. Closer 0.5 means more mixed. That means uncertain. Is it clear? We have key concepts are entropy and information gain. Entropy means it measures the uncertainty in a data set, and information gain means how much uncertainty is reduced after splitting the data based on a feature. In alternative split criteria means Gini impurity. It measures likelihood of misclassifying of randomly choosing data. So, next, advantage of decision tree. Here, first one is easy to understand and interpret. That means decision trees are visual. You can see the decision at each node. Even non-technical people can understand them. In the case of loan approval, you can follow the tree. If credit score is high and income is high, approve loan. Else, check other conditions. Clear? The second advantage is requires little data pre-processing. That means no need for scaling or normalization of features. Can handling missing values more gracefully than other algorithms. For example, you can feed both numerical data and categorical data directly. In the case of loan approval, we can feed income and age as a numerical data, and education, it can be used as a categorical data is directly. Next is handles both numerical and categorical data. And last one is fast prediction with logarithmic. Once the result is built, making the prediction is very fast. You just follow path from the root to leaf. No complex calculation is needed. Example, to approve a loan, the model just to check the relevant features in order to until it reaches a decision. Okay. There is mainly the 4 advantages of decision tree. The first one is easy to understand, and second requires little data pre-processing, and last one handles both numerical and categorical, and fast prediction with the logarithmic. Clear? Okay. Next, disadvantage of decision trees. First one is prone to overfitting. Decision trees can become too complex. Learning even they have noise in the training data instead of general patterns. Example. Suppose the tree splits repeatedly for every specific combinations of income and credit score and employment type. It may predict perfectly on the training set, but failing on new applicants because it memorizes the training data instead of learning general rules. Is it clear? The disadvantage of a decision tree is first one is prone to overfitting. That means the decision trees can become too complex, learning even any noise in the training data instead of general patterns. Example, suppose the tree splits repeatedly for very specific combinations of income, credit score, and employment type. It may predict perfectly on the training set, but fail on the new applicants because it memorized the training data instead of learning general rules. Is it clear? Next disadvantage is sensitive to small data changes. Even slight changes, sorry, sensitive to small data changes. That means even slight changes in the data set can produce a very different tree. For example, if one applicant's income changes from high to medium, the tree might choose a completely different feature for the root split. If one applicant's income changes from high to medium, the tree might choose a completely different feature for the root split. This makes decision tree less reliable if the data is small or noisy. Okay. Next, what is real world applications of decision tree? First one is customer purchase prediction and churn analysis. That means decision tree can predict which customers are likely to buy a product or which might leave. For example, any e-commerce company can analyze customer behavior such as age, past purchase, browsing patterns to decide who to target with the promotions. Next application is medical diagnosis and risk assessments. This decision tree helps doctors assess patients' risk or diagnose disease based on symptoms and test results. For example, a tree might help predict risk of diabetes based on age, family history, and blood sugar level. Okay, the third application is credit scoring and fraud detection. That means banks and financial institutions use decision trees to approve loans or detect fraudulent transactions or assign credit score. For example, the bank can use features like income or credit history and employment to decide whether to approve a loan or reject it. Last one, base learners in ensembles like random forest. That means single decision trees can be unstable or prone to overfitting, but combining many trees create a powerful models. Is it clear? Okay, then we go for a simple algorithm. Okay, this is decision tree algorithm. Here, first we import all libraries which we need. First one is import pandas, matplotlib, seaborn, and for loading iris, we using seaborn, and for train test splitting, we use sklearn model selection library, and we use decision tree classifier from sklearn.tree. And we use confusion metrics or classification reports accuracy score from sklearn. And for plotting tree, we use sklearn. First, we load the dataset into memory by using load iris. Okay. Then the iris data contains our features. That means measurement of sepals and petals, etc. Okay. Then iris feature names means that names of the feature. And x equal to pd dot data frame of, that means converts the feature into a data frame with a column name. Okay. First, we import all libraries. Second, we load the iris dataset. Then third, we map the target names for better readability. Here, our output will be the species column, that is Setosa, versicolor, and Virginica. Combine the features and target for exploration by concatenate x and y by using axis equal to 1. Then we plot, pair plot, that sees all the relationship between the features. Here we can see that there is a different columns, sepal length, sepal width, petal width, etc. based on the species. That is Setosa, versicolor, Virginica. The pair plot is actually given all the relationship between different features. Okay. Is it clear? Then we split our train data and test data in X train, X test, and Y train, Y test. Okay. Then we train our data set by using decision tree classifier. Here, the criteria using Gini. Already I explained Gini impurity. So here the criteria is Gini, that uses Gini impurity as the split criteria. And next, max depth. That means limit the tree depth. That's prevent overfitting. Next one is random state. It ensures consistency of result. Okay. Then creating a decision tree classifier, we fit the model. Okay, by using fit of X train and Y train. Is it clear? First, we import all libraries which are being needed. Then we import the iris dataset, and then we concatenate our X and Y for more readability. And then we plot pair plot for given all relationship between all the features. Okay, then we split our data set to X train and X test, Y train and Y test by using train test split off, which have test size 0.3 and random state is 42. Then we train our data set by using decision tree classifier. Here we using criteria is Gini impurity and maximum depth of the tree is 3 and random state is 42. Then we fit the classifier into X train and Y train. Is it clear? Okay. Then we predict Y value by using X test. For this, we use Y predict equal to predict of X test. Then find accuracy by using accuracy score, y-test and y-predict. Then I give a external new iris measurement as a data frame. Okay. Here the two measurements are given. First one is septal length is 5.1 and second is 6.7. Septal width is 3.5 and second one 3.0. The petal length is 1.4 and second one is 5.2. Petal width is 0.2 and 2.3. These are the external data to predict is correctly or not. This is given to our data model that will give sample 1 predict as a setosa. That means sepal length is 5.1, sepal width is 3.5, petal length is 1.4 and petal width is 0.2. The sample 2 predict as virginica. That means sepal length is 6.7, sepal width is 3.0, petal length is 5.2, petal width is 2.3. Is it clear? Okay.
Ma'am, somebody has asked to repeat the overfitting problem.
Overfitting. Am I right?
Yes, the overfitting problem.
Okay.
Okay.
Overfitting is a decision tree. In a decision tree happens when the model becomes too complex and memorize the training data, including the noise and random fluctuations, that rather than learning the general pattern. Why does it happen means decision tree splits the data into branches until they perfectly classify the training examples. If we don't limit the tree size or depth, it keeps splitting even on minor variations, leading to very deep branches that work perfectly on the training set, but perform poorly in unseen data. Is it clear? Overfitting in a decision tree happens when the model becomes too complex and memorize the training data. That means including the noise and random fluctuations rather than learning the underlying general pattern. Why it happens means if the decision tree split the data into branches until they perfectly classify the training examples. But if we don't limit the tree size or depth, it keeps splitting even on minor variations, leading to very deep branches that perfectly on the training set, but perform poorly on unseen data. Is it clear?
Yes, ma'am. Yes, ma'am.
Okay. Shall I continue?
Yes, ma'am.
Okay.
Hello, madam.
Yeah.
Madam, I have a question regarding overfitting.
Sorry.
Hello. I have a question regarding overfitting.
Okay.
Madam, suppose I train ML model and then I test the train ML model on unseen data, then how can I come to know whether overfitting occurs or not?
Sorry, I didn't clear.
Madam, suppose I train a model on training data set
Okay,
Hello,
training data set. Training data set.
Yes, and then the train model is applied to unseen data. So
Okay.
how can I come to know that whether overfitting occurs or not? Means how practically I can come to know that is the overfitting? Hello? Hello?
I think your question is just like, suppose we train a model
Yes.
okay, in a data set, and
Yes.
then and this model is applied to unseen data. Then how
Yes.
can know happen if it happen overfitting or not?
Yes, madam. Yes.
Okay. Actually, this is exactly how overfitting is usually detected in practice.
Okay.
Okay, if you compare the model performance on training data set, the purpose is data the model learned from. The unseen data means new data the model never saw during training. If
Yes,
the
madam.
model is well generalized, training accuracy is high. Testing accuracy is almost as high or similar. If the model is overfitting, training accuracy very high. Testing accuracy much lower.
Okay. Okay, madam.
Okay.
Clear.
In short, overfitting
Yes.
is indicated by a large gap between the training accuracy and testing accuracy. Is it clear?
Okay. Yes, yes, madam. Sure. It's
Okay,
clear. Thank you, madam.
Okay. Thank you. Okay. Shall I continue? Okay. Next is random forest. Random forests are used to overcome the limitations of individual decision tree. Actually, random forest is a machine learning algorithms that uses an ensemble of decision trees to make prediction. Instead of relying on a single tree, it builds many trees on different random samples of the data and uses voting mechanism to make the final prediction. This process helps the model generalize better to unseen data because the errors of individual trees are averaged out. For example, in a loan approval case, one decision tree may overfit to very specific applicant details. But when many trees are combined in a random forest, the overall decision is more stable or accurate and less sensitive to noise. Is it clear? Random forest is a machine learning algorithm that uses an ensemble of decision trees to make predictions. Instead of relying on a single tree, it builds many trees on different random samples of the data and uses a voting mechanism to make a final prediction. Is it clear? Okay, here random forest is reducing overfitting and improve accuracy. And random forest works mainly through two key techniques. First one is bagging. Another is random feature selection. What is bagging? Bagging means the algorithm creates a multiple random samples of the training data with replacement. A separate decision tree is trained on each sample. The predictions from all trees are then combined, majority vote for classification or average for regression. And the benefit of this is reducing the variance and prevents overfitting since no single tree dominates. Is this clear? Bagging or bootstrap aggregation. That means the algorithm creates multiple random samples of the training data, a separate decision tree trained on each sample. The prediction from all trees are then combined. Benefit is reducing the variance and prevents overfitting since no single tree dominates. Second one is random feature selection. At each split in a tree, only random subset of features is considered instead of all features. This ensures that trees are the trees are diverse and not all trees are rely on the same strong predictor. This improves accuracy and reduce the correlation between trees. Is it clear? Actually, the random forest works mainly through two key techniques. First one is bagging and second one is random feature selection. And bagging means that it's creating multiple random samples of the training data and the separate decision tree is trained on each sample. And second one is random feature selection. At each split in a tree, only a random subset of feature is considered instead of all features. This ensures that trees rely on the same strong predictor. Is it clear? Okay. For example, in the case of a loan approval case, bagging ensures that each tree sees different sets of applicants. And random feature selection ensures some trees may split first on income, while others may use credit score employment type. Is it clear? Random forests have two key techniques, bagging and random feature selection. And first one is bagging. For example, in the case of loan approval, bagging ensures that each tree sees different sets of application. And random feature selections ensures that some trees may split first on income, whether others may use credit score or employment type. The combined result is a more balanced and accurate prediction. Sorry. Hello. Any doubt? Sorry, I didn't get.
No, ma'am.
Hello?
No, ma'am. Somebody just accidentally unmuted themselves. You can continue.
Okay. So the key techniques, bagging and random feature selection. Next, how random forest works. Random forest builds multiple decision trees on different random subset of the dataset. Each tree makes its own prediction and then the results are aggregated to form the final output. Is it clear? Random forest build multiple decision trees on different random subset of the dataset, and each tree makes its own prediction and then the results are aggregated to form the final output. For a classification problems, the final class is chosen by majority voting. That means the final class is chosen by majority voting in the case of classification problems. In the case of regression problem, the final prediction is the average of all tree outputs. Is it clear? How the random forest works? Actually, random forest is builds from multiple decision trees on different random subset of a data set, and each tree makes its own prediction and then the results are aggregated to form the final output. In the case of a classification, the final class is chosen by majority voting, and in the case of a regression problems, the final prediction is the average of all tree outputs. For example, in the case of loan approval, if 7 out of 10 trees predict approved and 3 predict rejected, then the majority vote is approved. So final output is approved. Okay, if predicting a customer's loan amount, each tree gives an estimate and the random forest takes the average to give stable prediction. Is it clear? The example is clear. The case of a loan approval, if 7 out of trees are predict approved and 3 is predict rejected and the majority vote is approved. So the final decision is approved. If you're predicting a customer's loan amount, each tree gives an estimate and the random forest take the average of to give a stable prediction. Okay. Then, how random forest works step by step. Okay, session. This section can be walked through using a loan approval example. First step is create multiple trees with the bootstrap samples, sampling with replacement. First, from the full applicant dataset, say n rows. Each tree is trained on its own random sample of size n, and that means some rows repeat and some are left out, giving every tree a slightly different view of the world. This diversity reduces the variance, that means overfitting. Is it clear? Is it clear? Example, we're using a loan approval. First one is create multiple trees with the bootstrap samples. That means from the full applicant dataset, number of rows is n. Each tree is trained on its own random sample of size n.
Ma'am?
Yes?
There is a question in the chat box by Shankadeep. There is a question in the chat box. Can you hear me?
Oh, sorry. Yeah.
Okay, I'll read it out so that you don't have to close your presentation.
Okay.
The question is, how can this method be useful for agricultural economics? For prediction in supply chain analysis or profit analysis or production analysis?
Using a random forest?
Ma'am, that is not specified in the question. How, Shankadeep, if you can explain the question to ma'am, it would be really good. If you can unmute yourself and ask the question directly to ma'am, please. Shankadeep, if you're hearing me, please.
Yes, am I audible?
Yes, you are. You're perfectly audible.
Actually, the thing is that we are from a background, we are non-technical background scholars. So how can this machine learning methods can be useful for the specified studies? Anything that can be random forest or anything. How can we use in that particular sector? That is the basic question, madam.
Sorry, I didn't get. It's useful for agriculture? You mean agriculture?
Yes, ma'am. Yes, ma'am.
Random forest.
Yes, ma'am. For the predictive part. In case of the study where I can conduct a prediction analysis, how can you use this method? That is the question actually.
Okay, in the case of agriculture, how can we use random forest for predict? Am I right?
Yes, ma'am.
Okay. Random forest can definitely useful for agriculture prediction. And in the case of crop yield prediction or soil fertility classification or disease detection in plants, crop type identification, etc., we can be used for by using random forest. Why the random forest works well for agriculture data means it handles non-linear relationships and works well with the mixed features, that means numerical and categorical. And also it is resistant to overfitting. Is it clear? Hello?
Shankadeep, is it clear for you? Is it clear for you?
Okay, ma'am. Okay.
Okay. Thank you, ma'am. Continue. You can continue, please. Okay. Ma'am, am I audible? You can continue the class, ma'am. You can continue.
Okay.
Yes.
Okay. Our session is how random forest works step by step. In case of step 1, create multiple trees with the bootstrap samples. And step 2, at every split, consider only a random subset of features. That means instead of scanning all features, each node looks at a small random subset. Example, any features, 7 out of 10 features, and picks the split that best reduces impurity. We're using Gini impurity. This feature randomness correlation trace, so they don't all latches into the same stronger predictor. That means at each split, consider only a random subset of features. We not consider all features in a data set. We only consider random subset of a feature. In step 3, each tree predicts independently. That means once trained, every tree makes its own decision for a new applicant. That means approved or rejected. Individual trees can be a bit noisy, but that's okay. We are about to average out of the noise. Is it clear? In the case of random forest, step by step. Step 1, create. Sorry. Hello. Any doubt?
No, ma'am, nothing. Somebody just unmuted. You can continue.
Okay. In case of step 1, create a multiple trees with the bootstrap samples. And step 2, at every split, consider only a random subset of features. Not consider all the features of data set. We only consider the random subset of features. In third step, each tree predicts independently. That means once trained, every tree makes its own decision for a new applicants. In the case of in our loan approval example, each tree makes its own decision for a new applicant, means approved or rejected. In the case of classification, in the case of regression, it may be numeric value. Is it clear? Last step is aggregate all tree predictions for the final result. That means in the case of a classification, we use majority vote. Okay. If 7 out of 10 trees say approved, the forest predicts approved. In the case of regression, takes the average. That means if 3 trees predict the value 9.8 lakhs or 10.5 lakhs or 10.2 lakhs, the forest outputs above the average value. That means 10.7 lakh. Is it clear? The steps for random forest is clear. The first step is create a multiple trees, and second step is every split consider on a random subset, and in step 3 each tree predicts independently, and step 4 aggregate all tree predictions for the final result. In the case of classification, we use majority vote, and in the case of regression, takes the average. In simple words, first, start the selection of random sample from the given data set. Step 2, next this algorithm will construct a decision tree for every random subset of sample. Then it will get the prediction result from decision tree. In the step 3, voting will be performed for every predicted result. In the step 4, select the most voted prediction result as the final prediction output. Okay.
Ma'am,
Yeah.
can you elaborate these 4 steps by using any real-time example?
Using iris dataset?
No. These previous 4 steps, can you explain with the real-time example?
Using loan approval example, is it okay?
Yes.
Okay. In the case of loan approval example, we create multiple tree. First step is creating multiple tree. Okay, actually the random forest is built on a multiple decision trees. So first step is creating the multiple trees by using our decision tree. Okay. Next step is we consider in one decision tree, we consider only random subset of feature. Okay. Third step is each tree predict independently. Okay. First, start with the selection of random sample from a given data set. In the case of loan approval, we taking n rows. Okay. In step 2, algorithm will construct a decision tree for every sample. Then it will get the prediction result from every decision tree. Okay, in step 3, instead of scanning all features, each node look at small random subset of our data set and picks the split that best reducing impurity. This feature randomness will used to same stronger predict. If in this case we can use a credit score. Okay, then in the third step, each tree predict independently. That means if one tree is predict for a new applicant is approved, or other trees in other tree can be predicted is rejected. In the case of classification, can be approved or rejected. In the case of numeric value, is used for regression. And final step is means that in the case of classification, the majority vote. That means if 10 trees are if 7 out of 10 trees says approved, the forest predict approved. Is it clear?
Yes, ma'am. Yes, ma'am.
Okay. In the case of regression, for example, if 3 trees predict 9.8 lakhs, 10.5 lakhs, and 10.2 lakhs. Okay, these are numerical values. So the random forest output must be the average of 3 trees output. Is it clear? Okay. Next, we go for advantage of random forest. The first is high accuracy. Random forest combines the power of many decision trees, which leads to very strong predictive performance. Since the final result is based on aggregate of multiple trees, it usually performs better than the single decision tree. Okay, for example, in the case of loan approval, instead of trusting one tree's decision, the random forest combines many trees, leading to a more reliable approval or rejection outcome. Is it clear? The random forest have high accuracy because random forest combines the number of many decision trees, which leads to very strong predictive performance. Second one, handles large data set well. That means random forest can efficiently process data sets with thousands of rows and many features. Okay, it works well even with mixed data type. That means numerical and categorical values. For example, in banking sector, with a huge data sets of applicants, income, spending patterns, and credit history, or the random forest can handle the scale without performance issues. Is it clear? Next, reducing overfitting. A single decision tree may memorize the training data, that means overfitting. But random forest reduces this problem. By averaging predictions from multiple trees, it smooths out noise and avoid the extreme rules. Okay, for example, one tree may incorrectly reject an applicant due to an outlier in income, but when averaged with other trees, the forest still makes the right decision. Is it clear? Our advantage of random forest, first one is high accuracy. High accuracy means its random forest combines the power of many decision trees, which leads to very strong predictive performance. Since the final result is based on the aggregate of multiple trees, it usually performs better than the single decision tree. And second is handle large data set. That means random forest can efficiently process data sets with thousands of rows and many features. And also it works well even with mixed data types. That means numerical and categorical. Last one is reducing overfitting. A single decision tree memorize the training data. That means overfitting. But random forest reducing this problem by averaging the predictions from multiple trees, and it smooths and avoid extreme rules. Is it clear? Next is disadvantage
Hello,
of
ma'am. Ma'am, there is a
Hello?
question in chat box. There's a question in chat box. It's from Srinivasan. Do you have any comparison with any other algorithms? The question is, do you have any comparison with any algorithms?
With the random forest.
The question is not complete. So,
Okay.
Mr. Srinivasan, can you please complete the question? Ma'am, you continue. Ma'am, you can continue after maybe the person will ask the question later. You can continue the class.
Next disadvantage of random forest. It is computationally expensive because the random forest builds hundreds or even thousands of trees, which requires more time and memory compared to a single decision tree. Training can be slow if the data set is very large or if too many trees are used. For example, in real-time fraud detection, with the millions of transactions, so the random forest may take longer to train compared to simpler models. Next one is less interpretable. That means a single decision tree is easy to visualize and explain. But with a random forest, since it combines many trees, the final prediction is based on an ensemble, making it more like a black box. That means if in loan approval case, you can explain the decision true, like if credit score is greater than some amount and income is greater than some amount. But with the random forest, the decision is the result of many trees voting, which is harder to explain the stakeholders. Okay. Next is applications of random forest. First one is fraud detection. Random forest can analyze transaction patterns to spot unusual or suspicious activities. For example, in banking, it helps detect the credit card fraud by distinguishing between normal and abnormal spending behavior. Second is healthcare predictions used for disease diagnosis, patient risk assessments, and medical research. For example, predicting whether a patient is high at risk of diabetes or heart disease based on lab result and lifestyle features. And third one is e-commerce recommendations. Helps predict what customers are like to buy next or whether they might stop using a service. For example, online retailers like Amazon can recommend products by analyzing past purchase and browsing history. Last one is stock market analysis. Random forest can process large amount of financial data to predict trends, risk, or price movements. For example, forecasting whether a stock price is likely to rise or fall based on historical prices and economic indicators. Okay, let's conclude. Decision trees are simple, and easy to interpret, making them very useful for basic classification and regression tasks. However, they can easily suffer from overfitting if not carefully proved. Random forest, on the other hand, is an ensemble of multiple decision trees that works by combining their predictions. This approach provides higher accuracy, better generalization, and significantly reduce the risk of overfitting through averaging. Together, these methods show how we can start with simple model-like decision trees and then move towards more powerful ensemble techniques like random forest for solving complex real-world problems. Okay? Clear? Today's section, we will cover our random forest algorithm and our decision tree. And decision tree is actually, the decision tree makes yes or no answers. Am I right? If it have some anatomy, that means root node, internal node, branches, and leaf node. Okay, and we have in the case of decision tree, we making two metrics are used for splitting, that is Gini index, entropy, and information gain, etc. And one example, and also we use entropy and information gains, etc. In last section, we discuss about random forest. Random forest is actually Actually, the random forest nothing but it is the mix of, or it is modeled by using a multiple decision trees, and they, in the case of classification, it will be taking the voting method. In the case of regression, we're taking the average method. Okay.
Okay, thank you, ma'am.
Okay.
Ma'am, we have a question in the chat box. The question is, can decision tree and random forest algorithms can be used for unstructured data like images? Hope you can see the chat box.
Okay. Okay, can decision tree and random forest algorithms can be used for unstructured data like images? Am I right? Actually, a decision tree works by splitting features into branches based on their values. So it's not good for in the case of images. In the case of images, we're using convolution neural network. That means we converting the images into arrays, and we using a convolution matrix for this. It's actually the decision tree and random forest is not good for unstructured. What? It is not good for unstructured data. Hello?
Sorry, ma'am.
Hello?
Someone accidentally unmuted it.
Okay.
We continue.
Okay, that's all. That means the decision tree and random forest is not good for unstructured data like images. In the case of images, we can be used convolution neural network for predictions.
Okay, thank you, ma'am. If there is any queries left to the participants, if you have any questions, you can directly ask to ma'am. Or you can convey your feedback. Okay, I think There is no more queries. So, ma'am, we are winding up this session. Thank you, ma'am, for such an enriching session on the supervised learning. And you mentioned about the real world application like fraud detection, healthcare protection, and more. And you explained decision trees, random forest with the practical application. And also in between, you cleared all the queries of the participants. And I believe everyone has gained valuable insights from the session. Thank you, ma'am. Thank you for your effort.
Okay, thank you all for joining the session today. I really appreciate your time and participation. Hope you found it valuable. Wishing you all the best.
Thank you, ma'am. Thanks a lot.
Okay, thank you.
So, dear participants, the feedback form for session 6 is posted in your chat box. Please fill it. So, before leaving, there is a just quick update that the list of approved participants are already been shared in the WhatsApp group. A gentle reminder that some members here might have only applied for FDP, may not be, maybe their application is not approved. So keep in mind that the approvals were given strictly as per the participation limit. If anyone missed their names in the list provided in the WhatsApp group, please log in into your ATAL portal and check your status whether it is showed approved or applied. And note that the approvals are finalized only through the ATAL portal before the program starts. So only participants marked approved on the ATAL portal will be considered as the official participants of this FTP. We regret that no further applications can be accommodated now. And thank you for your consideration. And one more thing, that the session materials, the slides of all the sessions have been uploaded to the Google Sheet shared in the WhatsApp group. You can kindly go through them for your further learning and references. I hope you enjoyed today's session. You can just fill your feedback form and you can leave. Thank you all. Good night. Those who have filled the feedback form, you can leave.